Hello and welcome back to the channel. Today we're going to be looking at recursion. A recursive function is a function that calls itself. It might seem complicated at first, but if we look at it through an example, it would be very simple. So we're going to first create our file and we're going to call it recursion.c. Then we're going to put in our template code, #include stdio.h. Then we're going to have a comment for our main function, which is going to explain recursion. Then it's going to return 0 as usual. Then we're going to write our main function, which is going to take no parameters, so it's going to be void. And before we get started writing in our main function, we need to first create our recursive function. In this video, we're going to be creating a function that executes a factorial. From your maths lessons, you've learned factorial, which is, for example, if we want the factorial of the number 5, which is represented by 5 followed by an exclamation mark, this is equals to 5 times 4 times 3 times 2 times 1. This is what a factorial is. And as you can see, there is some sort of pattern. So for example, 5 factorial can also be written as 5 factorial times 4 factorial. It can also be written as 5 times 4 times 3 factorial. So we're going to be using this pattern to write our factorial function. So we're going to create our function. It's going to return an integer. So we're going to write int, we're going to name it factorial, and it's going to take in an integer n. So inside our factorial function, so when we deal with recursive functions, we usually have a base case and the recursive part of our function. The base case is used so that our recursive function does not run infinitely. It stops our recursive function. So in this case, we need to think of the simplest form of a factorial. In our case, it's going to be when n is equals to 0 or 1. That is the simplest factorial you can do, which is going to be equal to 1. So we're going to write that using an if statement. So it's going to be if n is equals to 0 or n is equals to 1, we want to return 1, as the factorial of 0 and the factorial of 1 are both equal to 1. Now to write our recursive part. We're going to write our recursive part in an else statement. So we're going to have an else statement, and inside our else statement, we're going to be returning n times, we're going to now call our factorial function again, and we're going to pass into it n minus 1. Now, this might seem complicated, but if we look at it step by step, it is actually easy. So, as our previous example, let's take 5 again for n. So, it checks the if statement, n is not equals to 0, and it's not equals to 1. So, it goes to the else statement, so it's going to be 5 times factorial of 5 minus 1, which is 4. So now it's going to evaluate factorial 4. It's going to run through the steps again. Then factorial 3 needs to be evaluated. Then it runs through the steps again. Then factorial 2 needs to be evaluated. And finally, we reach 1. So when we reach 1, it's going to enter the if statement and it's going to return 1. That's what breaks our recursive function. So that's all we need in our recursive function, so we can close it. And we're going to go back to our main function. And using what we learned in the taking inputs video, so we're going to be taking n from the user. So first we need a variable to store it. So we're going to have an int called num. Then we're going to be using the scanf function, which is going to be expecting an integer, so we're going to use the %d identifier, and it's going to store that integer in the variable num. Now, to make it more clear, we can add a prompt for the user using printf. We're going to say enter a number. This is going to be a prompt for the user. Then we're going to scan what they enter and we're going to store it to num. And finally, we are going to initialize another variable that's going to store the result. And we're going to set it to the factorial of num, which is the number we took from the user. And we're going to finally print out our result. So we're going to use printf. Now, to make this more clean, we can use the %d identifier followed by the exclamation mark, which represents factorial. We can say this is equals to %d. Now, in our first %d, we want the num that the user provided, so we're going to put in num. And in the second %d, we want our result. Finally, we can return 0. And we can close our function and see if it works. So we're going to save our file and we're going to use the GCC compiler. This is good, it compiled with no errors. Now we can run it using ./a.out. It's asking us for a number, so let's take the example we did before, which is 5. So it's going to be 5 times 4, which is 20. 20 times 3, which is 60, 60 times 2, which is 120, so it should give us 120. As you can see, it gives 5 factorial is equals to 120. Now, we forgot to add the new line character, so we can go back to our code, and in our print statement, in our printf statement, at the end we can add a new line character. And we can save our file, compile it again. Remember, if you make changes, you need to compile your file again. Now we can run a.out, enter a number. We're going to enter 5. And as you can see, 5 factorial is equals to 120. There are many applications for recursion. This is just a simple problem, but you'll also find exercises in the description. And this is all about recursive functions in C.
As always, you can find the video code in the description, and you'll also find exercises with their solutions. And thank you for watching this video, and don't forget to like and subscribe for more programming videos.